we're going to take a look at dilution. And we deal with dilution in our everyday lives. To dilute a solution, we just add water. Now, the diluted solution will always have a higher volume than the original solution because we're adding water, and it will also have a lower molarity. The diluted solution has the same number of moles as a solute as the concentrated solution, because all we've done is add water, but it has a lower molarity, moles per volume of solution, because we've added water. So dilution problems always deal with two molarities and two volumes. The molarity and volume of the concentrated solution that we start out with, and the molarity and volume of the dilute solution that we end up with. And the concentrated solution is sometimes known as the stock solution. Here is the equation for all dilutions. M1V1 equals M2V2, where the ones indicate what we're starting with, so the concentrated solution, and the twos indicate what we're ending up with, or the dilute solution. So M1 is the molarity of the concentrated or stock solution. V1 is how much of that stock solution we start with. M2 is the molarity of the diluted solution, and V2 is the volume of the diluted solution after we've added the water to it. So the molarity of the stock solution, or what we're starting with, is always greater than the molarity of what we end up with. And the volume of what we start out with is always smaller than what we end up with. So it's important to kind of wrap your head around those, so when you get answers, you can see if they make sense. Now, we have four variables in this equation, so there are four ways we can manipulate it depending on what we are solving for. So if we're solving for M1, we multiply M2V2 divided by V1. If we're solving for V1, the volume that we start out with of the stock solution, that's M2V2 divided by M1. If we're solving for the final molarity, sorry about that. We're solving for the molarity of the dilute solution, it's M1V1 divided by V2. And if we're solving for our final volume of the diluted solution, that's going to be M1V1 divided by M2. So it's pretty straightforward. The solving strategies that I use are just clearly identify what you're given, what values you're given. You have to be given 3 on what you're solving for. And you can use your units to really help you. Molarity or molar is always going to be the concentration, or the M1 or M2. And volume will always be in some unit of volume, such as liter or milliliter. So once you identify what you're given and what you're solving for, then it's pretty easy to choose the correct equation. Now, the one thing you have to be careful of is that the volume units have to be the same, because you want them to cancel out. They don't have to be liters, but they do have to be the same. So let's just start off by looking. So if we read this, what volume of a stock solution of 18 molar sulfuric acid is needed to make 100 mils of a 3 molar solution? So what I'd like you to do is I'd like you to stop this and try and figure this out on your own. And the first step is to clearly identify what values you're given from the equation M1V1 equals M2V2. When you're done, start the video again and we'll review the answer. So I don't know about you, but for me, this first step is the most time consuming, taking the time to figure out what is what. So the stock solution, or the concentrated solution that we're starting with, has a molarity of 18 molar. We're solving for what volume do we use. We want to end up with a dilute solution whose molarity is 3 molar. Notice that's less than what we started with, and a volume of 100 milliliters. So this volume is definitely going to be less than 100 milliliters. So now that I've identified what I'm given and what I'm solving for, I know that this is the equation that I'm going to use. So I just plug in, and notice that my molarity units cancel out, and when I express my answer with correct sig figs, this only has 2, so my final answer, and yeah, I can only have 2, it's 17 milliliters. So what this means is I would measure 17 mils of my concentrated solution, and then add enough water until I got 100 milliliters. And at that point, I'll have a diluted solution with a molarity of 3 molar and whose volume is 100 milliliters. Let's look at another one. A 2 milliliter aliquot. That's just a fancy word for portion. We usually use it when we're talking about an amount of volume. So a 2 milliliter aliquot of a 1.75 molar stock solution is diluted to 100 milliliters. What is the molarity of the diluted solution? So again, I want you to stop the video and see if you can figure it out, and once you get it, we'll review it. Okay, again, first thing I want to do is identify what I'm given. I'm given the concentration of the stock solution, which is the more concentrated. I'm given the volume of that concentrated solution, and I'm trying to find out what the molarity of my dilute solution is when my final volume is 100 milliliters. So since we're solving for the molarity of the dilute solution, this is the equation that I use, and we can see that my volume units cancel out, so they have to be the same. And expressing my answer with 2 sig figs, I get 0.35 molarity. And so what this means is when I have 2 mils of 1.75 molar and I dilute it, add enough water to get to 100 mils of solution, the resulting or final molarity is 0.35 molar. So notice that this molarity is smaller than my original molarity, and my final volume is larger than my initial volume.